Hello and welcome to the Fundamentals of SQL course. We are in the join section and we are discussing full joins. So the goal of a full join is to find that mismatched or orphan data from both of your tables, and you just want it in one result set and not just matches. So this can be helpful when you're trying to compare data from two different databases to kind of identify nulls in different columns and to see if you have mismatched or differing data. So let's say we have customer data from our database in table A. So we also have different customer data in another database in table B. We can do a full join to find any duplicates in each table or to compare the two table structures. We could also use a full join to find out any null values in one table compared to the other, or find any missing information in one of the tables compared to the other. So really, we're using full joins to compare two tables from different databases. It is the same syntax as a inner left and right join. We just replace the inner left or right with full. So let's say we want to provide all the first 100 rows of data of customers and address information. Great, so we are going to select all of our information from the DVD customer table, and we're going to full join the DVD address table on the address ID, because that is the column that they share. If we go to our database objects and identify both tables, so let's look, DVD address has the address ID, and then if we go to DVD customer, it also has an address ID. So we know that we can join those two tables on those similar columns. And then we just limit it to 100 rows. So on the left, we're going to see all of our information from the DVD customer table, and on the right, we're going to see everything from our address table. And that would be a full join. Usually, a full join would be covered in null values, just because real data isn't as clean as this sample database data, and that's okay. But just remembering that when we use full joins, we are using them to find that mismatched or orphan data, or to compare table structure if we have similar data in both tables from different databases. So that is full joins. In our next lesson, we're going to be discussing self joins. Thanks, and I will see you in the next lecture. Hello and welcome back to the Fundamentals of SQL course. We are in the join section and we are going to be discussing self joins. So the goal of a self join is to compare values within the same table. So we can use a self join to reference itself, and a common use case is when a table stores records and they have hierarchical relationships between them. So let's say we have an employee table where every employee has a manager, and that's kind of a hierarchical relationship. And you want to list all employees and the name of their manager. You can do that using a self join by comparing the table to itself. And we'll talk through an example using our pets table, or our pets owners table and pets data. So let's do a self join to match the owners from the same city and state using our pets owners table from our pet data. So best practice always let's refresh our memory of the table schema by selecting our pets owners in our database object. So we have 89 rows. We have the owner ID, the name, surname, street address, city, state, the full state, and our zip code. So we want to know the first name, the surname, the city, and state to compare the owners from the same city and state. So in a self join, we have to create columns and table aliases to simulate creating two tables to join together. In this example, A and B are aliases for the same pets owners table. So I didn't want to type this out as we went along. I want to break this down with you. So let's look at our select statement. We are selecting table B, which is the table that we are creating. We are aliasing dot name as first name 1, and table B dot surname as last name 1. So this is just saying that from table B, the name column is now first name 1, and the surname column is last name 1. And then from table A, our name as first name 2, and table A, our surname as last name 2. And then we're just going to call the city and state from table B. Now, table A and table B are aliases, and you're probably thinking, like, where did we create these tables? Where are these coming from? What's going on? So when you're writing, we can create these tables, or these table aliases, and then when we call them in our from statement, we just re-alias both tables as what we want. So we're going to say from pets owners, table A, comma, pets owners, table B. So we've re-aliased pets owners and replaced them with table B and table A so we can simulate a join together. And now down to our goal where we want to match the owners from the same city and state. So when we compare, we don't want to compare the owners with themselves. That would be redundant. But we do want the city and state to equal each other from table A and table B. So we're going to use a where statement to filter out our data of owner IDs where they don't match from either table. And remember, this less than greater than means not equal. So we're saying select all of this information from pets owners table A and pets owners table B where the owner ID from table A does not equal the owner ID from table B. Great. We're also going to use logical operators and to show that we want each city from table A to match each city from table B. And we want each state from table A to match each state from table B. And that's going to filter our records for us to show what we want to show. And then we order by state. So let's highlight this, let's run it and see what we get. And this is exactly what we wanted. Now we have our first name and first name 2 and last name 2, and we're matching all of the owners that live in the same city and we're ordering it by our state. I urge you to explore the data from this self-join and kind of see what happened. And in the practice on Teachable, you're going to get more examples of how to use self-joins, and they're going to be very similar to this, so I suggest you use this as a template from your notes. You won't necessarily understand self-joins to a complete extent, and that's not necessarily the goal here. It's just to expose you to what you can do in SQL. The more you use self-joins, full joins, right joins, left joins, inner joins, the more you're going to understand them. So just remembering that a self-join, the goal is really to just compare values within the same table or use them to identify hierarchical relationships between values in a database. That was self-joins. Thanks, and I will see you in the next lecture. Hello, and welcome to our final section on joins in the Fundamentals of SQL course. We will be discussing unions. So the goal of a union is to combine data into new rows. So where joins combine columns, unions combine rows. And I think of this like stacking tables on top of one another. But the thing about unions is that the column names must match, and they have to be in the same order in a union, or it won't return any results. So the columns names must match to a character extent, capitalizations, everything. everything has to match and be in the same order or it won't return any results. So I wrote out a query, as you can see, that lists the first name, last name, the purchase, and the purchase date. And this is from our purchases table. We have 3 of them in the DDN data warehouse, and it is purchases April, March, and May. And these were just created. They're very small tables. They were created just so we could practice unions and just be able to see what happens. So let's say we run just the purchases from March, and let's just look at our data and see what we have. We have first name, last name, the purchase amount, and the purchase date. But these are all purchases from March. Okay. So we want to see all of the purchases from April from a different table. Well, since I want to see these 4 columns, I'm going to have to call out these 4 columns again. And how we join these 2 together, or how we union them together, is we write union. So we have our select statement from our table, and then we write out union, and then we write our another select statement. So we are unioning the March table and the April table for our purchases. So if we run this query, we're going to stack on top of each other or combine rows. As you can see, we now have 200 rows. That means the union was done successfully. And you will see that we now have purchase dates for April and March. There's another use case of union, which is union all. So if we use simply just union, it's not going to show duplicates. But if we use union all, it will show all of the duplicates. Because our data is so small and it's simply used for practice, there's not a difference when we write out union or union all. But in real-world use cases, when you use union all, you're going to return everything. When you use union by itself, it won't return any duplicates. So that is the entire joins section. Thanks, and I will see you in the next section.